Picking back up, I have already done the vertical. I've got my free body diagram. I haven't forgotten my weight and my normal force. I'm doing a vertical problem, so I've got to have my weight. I'm going to need my mass, so this is what I'm going to do right now. I don't have an angle to worry about, and then I'm going to break it into the x and y parts and do them separately. So I know that the mass is equal to 3.06 kilograms, and from that I can find the weight. And you can always find one from the other using this equation, m times g. So this particular case would be, and I believe it's 30 newtons. Right? I can go ahead and place that over here. And I have all my numbers figured out, everything's nice and labeled, and I'm set to just sum the forces in each direction. So I've gone through all these steps, everything's found and taken care of and labeled nice and neat. So I'm just going to sum the force in the y direction, set it equal to m times ay, and sum the force in the x direction and set it equal to m times ay. Let's start with just the acceleration. That's an x thing. So I'm going to sum the forces in the x direction and set it equal to m times ax. That is always true, and that's how you start. In this case, I have three forces. On the left-hand side, I'm just writing down all the pink forces, horizontal ones, and with the appropriate positives and negatives denoting direction. And that's why arrows are important and necessary up on your free body diagram. So I have the force of Carla is forward, so it's positive. The force of Bob is positive, and then the force of Dave is backwards. And on this other side, I still just have max. And then I'm going to plug in the numbers. 5 plus 10 minus 17 equals, my mass is right here, easy to find, ax. So I have minus 2 equals 3.06 ax, and then I'm going to solve. I'm just doing algebra. Divide by 3.06. And this gives me the acceleration in the x direction is equal to negative 0.654, or you could label it some sort of verbal descriptor. I could also say 654 meters per second squared to the left or to the west or anything like that. And I'm done with just the AX part. Then another part of the problem, and I have to do this just because of being asked for both, is find the normal force. So I'm going to sum the forces in the y direction this time. So if I sum the forces in the y direction, MAY, and you should always start like this. This is how everything starts. Again, on the left-hand side here, I'm just going to write down all the forces that I have that are in the y direction. Normal is up, so it's positive. The weight is down. And then what you're doing with your applied force, it depends on the situation. In this part, Alice is pushing down with 6, so that is why FA here is going to be negative. Then on the right hand, I have M, and then specifically, because this is a sitting on a surface problem, I know that AY is always going to equal 0, and that's this anytime I have something on a surface. So you need to know that. So I'm going to fill in Fn minus 30 minus 6 is equal to, and this whole side becomes 0. So the normal force is equal to 36. And you're done.